Hey, good afternoon. Listen, I'm a DTLP grad, so I was hoping I'd get a little bit more from the DTLPs out there. But I appreciate you having us here this afternoon, and I'm very pleased to be with Mike Campbell from PTC. You're going to be hearing a lot more from Mike in just a moment, but I first want to tell you a little bit about GE Transportation and our service operation, and we're going to show you some really cool stuff today. I think this is a great extension to Seth's presentation. I think he did a tremendous job laying out how we're marrying an industrial brawn with the analytical brain to unlock game-changing potential for our customers. And what you see from Seth is that's extending into the global supply chain networks for the customers in the industries that they serve. And what we're trying to do is take some of that technology into our internal supply chain to also get value. So at GE Transportation, we have over 20,000 locomotives in service worldwide. And at the heart of that product is the diesel engine. And just like with your cars, we need to maintain, service, and sometimes repair that engine. And we do that today in a factory in Grove City, Pennsylvania. And that all comes to Grove City, Pennsylvania. So that's 1,000 engines. That's over 12,000 components a year. That's a lot of work to do. So we've had to evolve our processes, right? Not only just to meet the increased volume of demand, but also to ensure that we're really driving the new advanced manufacturing techniques and processes to ensure the best quality for our customers. So it all starts with the asset, right? We leverage Predict's asset performance management to truly create a digital twin. We author analytics on the Predict's platform that generates alerts that help tell us what needs to be maintained and when it needs to be maintained. So we're arming assets with sensors. We're streaming performance data off of our locomotive. We're aggregating data from our enterprise systems. And at the end of the day, this is creating powerful insights for our product. And now we're working to combine PTC's ThingWorx technology with Predict's to optimize how that information is delivered to the right people at the right time. So together, we're reimagining the service and repair experience, and I'd like to turn it over to Mike, and let's show him how.
That's great. Thanks so much, Nate. It's a pleasure to be here today. PTC and GE announced an expanded partnership, and I'm really honored to have the chance to share with you how our two companies are working together to help you bridge the digital and physical worlds. And we'll show you how you can do that using ThingWorx for Predict's technology. Now, this technology will deliver the power to do a few important things. The first is to aggregate data from across the enterprise, certainly from APM, but also from other systems like maybe CAD or PLM and engineering. ThingWorx application enablement platform will allow you to very easily, using drag and drop, create dashboards and mashups to expose this information. And also, finally, this suite will also magnify the power of Predict's, the value of Predict's, by allowing you to easily create incredibly compelling augmented reality experiences. These will allow you to visualize all of this rich information in the context of the assets themselves right here in the physical world. Now, to demonstrate the power of this great technology, we'll walk through a service scenario that might be performed on a locomotive engine. And we would like to have had the locomotive engine here on the stage. It's not quite logistically possible because of its size and weight, of course. So what we have is a 3D printed scale model. And I'm going to invite my colleague Pierre out here to act as the service technician. So we're imagining that the engine has come into the shop. We're beginning the triage process. And what Pierre is doing, you'll see his tablet displayed on the screen there. What he's doing is he's scanning a marker on the side of this scale model. And that marker is a unique identifier, and it's allowing the application to load information that is uniquely tied to this specific engine. And it provides access to all of the relevant information that he needs. Now, we're using the ThingWorx view on the iPad to scan that thing mark, and it's been dynamically loaded. And what you can see here is the information that the service technician needs, the details about this engine, the locomotive number, the customer that owns it, as well as the initial diagnosis of the repair that needs to be done in the top right corner. And this has been derived from analytics that have been performed on the engine data and performance alerts, of course. In this case, the type of service event that we're having is an event-driven repair. So we'll dig into some of the additional, some of the deeper details on the condition of this asset so that we can determine the right repair process.
Sometimes they need to go to offline systems. There we go, that sounds a little better. Then we need to go to offline systems to validate information about that engine, and that all is cycle time, right? So the ability to have this information at the point of receiving the product is really powerful and will really help us reduce lead times.
Okay, so what the technician will do next is he's going to review the different subsystems. And we can clearly see that most of the subsystems are healthy, but one, the oil subsystem, needs our attention. And we can interrogate each one of these, and we can also see exactly where each subsystem is in the context of the engine itself. Now, we're going to drill deeper into the health of the red oil subsystem and inspect the underlying sensor data that shows the actual time series information from the sensors. And clearly, we can see that the oil pressure is degrading. It's dropped below our minimum threshold here.
So what we've been able to do here is reach into our remote monitoring and diagnostics system, and we've pulled data from the last known operating time frame within a locomotive. So Predix Analytics helps us derive alerts and expose the specific subsystems and/or components that we should be paying special attention to during the triage.
Now, each power assembly, these are the piston assemblies, there are 12 of them on top of each cylinder, has undergone an analytics process and has determined their health status. And this drives unique condition-based work scopes that are shown here in the table on the left. And of course, each one of the power assemblies is also color-coded to represent the recommended work scope that is required for each one of these power assemblies. Now, these analytics derive the useful remaining life by considering data from APM, such as the asset configuration information that's based on serialization, and the hours that each of these assemblies has been in use. And this derives the status, which again you can see clearly presented without any ambiguity at all.
So the flexibility to perform this kind of personalized medicine on these engine components is really powerful. It allows us to repair based on operating history of the asset, and we can apply a very precise work scope. So this ensures that we're limiting the costs of poor quality for our business and also providing the most reliable product back to our customer.
Now, service technicians may also want to see other relevant and recently updated data about the parts in the engine. For example, in this case, there's a batch recall on some of the power assembly's injectors. And again, by leveraging the data and analytics and the power of augmented reality, the technician is clearly presented with sort of an X-ray vision view showing which specific injectors need to be replaced, as well as the supplier recall data and the relevant supplier information. Now, of course, these affected components have to be taken out, and ThingWorx for Predix can be used to provide the technician with the proper procedure to do so. So to demonstrate how ThingWorx for Predix can make this work more efficient, we actually have here on the stage a power assembly. And because each power assembly is different, again, Pierre is going to scan the ThingMark and get the relevant information for this particular procedure. Note that today, we're showing you this information on a tablet, so we can show you it on the screen. You can see what Pierre sees. But in the shop, this information could be presented on digital eyewear, something like a HoloLens or other glasses that allow the digital information to be overlaid on the physical world. What Pierre will see next is the step-by-step instructions that inform him on exactly how to open up the power assembly and access the affected injectors. Now, this is an outstanding example of bridging the digital and the physical worlds and delivering exactly the information that's needed to get the job done. And this technology can be equally applied to training scenarios, step-by-step instructions on the shop floor, as well as in the repair facility. So I hope you'll agree that this is some amazing capabilities, some pretty compelling capabilities that we're working on. Delivering this relevant digital information in the context of the physical world is going to have a profound impact on how we all do our jobs. And the combination of GE's Predix and PTC's ThingWorx is not only what makes this possible, but also what makes it incredibly easy for you to create experiences just like the one that you saw here.
So look, these advances really are going to help us continue to deliver game-changing outcomes and potential for our customers and industry. I'd encourage you to take the opportunity to look at Predix APM, check out the new ThingWorks for Predix, and I hope it'll be advantageous to providing outcomes for your business as well. Thank you.
Thank you.